During our last video, we discussed how we can install UnSloth on Windows. We will now use it for training a model. For fine-tuning, we will use Qwen2 7 billion parameter model. This version was released last October by the ML team from Alibaba. For Qwen2, they had released a number of base models as well as chat models ranging from zero point 0.5 to 72 billion parameters, including a MOE model. This model generally surpasses most open source LLMs in terms of language understanding, language generation, multilingual capabilities, coding, mathematics, and reasoning. For the fine-tuning instruction dataset, we will use a clean version of Alpaca, which was created by Yahama, who is actually a robotics engineer working for a hedge fund. The original dataset was released by Stanford, and the text was generated by using OpenAI's DaVinci model. The dataset had a number of URLs and also empty inputs, as well as a mixture of wrong answers with unclear instruction sets. Having removed that, this created a higher quality instruction data set, which can be used for fine-tuning your models. By using UnSloth, it becomes a very simple function of loading the pre-trained model and then starting a SFT trainer on the required data set. We start first by importing the necessary functions like the fast language model and the tokenizer utilities. The Qwen2 7 billion model is then downloaded from UnSloth's Hugging Face repo. Note that the D type is kept as none for auto detection. We are also downloading their 4-bit models. If you were using a gated model like the Llama 2, then probably you'll also have to give the token, the Hugging Face token for that purpose. UnSloth uses parameter efficient fine tuning, which allows you to fine tune only a small subset of the parameters instead of the entire model. This reduces computation cost and memory requirements. I now define a formatting from prompt function and load a required dataset. Finally, a SFT prompt of SFT trainer is defined. Since I have a 3090 NVIDIA GPU processor, it has about 24 GB of RAM, virtual RAM, out of which only around 3.4 gig is being used. I then start the training function. We are training for 60 sets. This can also be changed to one epoch, which takes around 4.5 hours on my setup. But at the end of it, we want to know how much time did it take to train a model, as well as the peak reserve memory.
A few moments later.
As you can see, we have completed training slightly more than 2.5 minutes, and the peak reserve memory is only 8.9 GB. That's about 14% of the total available memory for us. Let's try out the model by asking it to continue the Fibonacci series. Note here that we have used a maximum token of 64 only. Let's use the text streamer function from transformers to stream the output tokens. And we will also use a higher maximum token of 256. As you can see, we get more numbers in the Fibonacci sequence with a higher token limit. But I will now use the save pre-trained function to save the model and the tokenizer in a local folder. The model can also be pushed to the Hugging Face hub using push to hub function. I'm really excited by this potential of using UnSloth to train small language models or SLMs for specific purpose. If you are equally excited, let me know what your use cases are.